Hello everyone, myself Ranjit Kesi, working as assistant professor at Department of CSE, MIT Mysore. I will be handling your subject called Unix programming, a 5th semester course. In today's session, we will learn about a file lock mechanism and we will learn on directory file APIs, device file APIs, FIFO file APIs and symbolic link file APIs. So let us start with the very first topic, that is an file and record locking. Well, as we are quite aware, Unix is said to be a multiprocessor environment. Mean to say, at parallel, it can run one or more number of processes at same time. And with this, Unix also facilitates a multiple process or more number of a process to access a common resources. For example, two or more number of process accessing the same file for their own operation, whether it may be a read operation or whether it is a write operation. At these consequences, what exactly happens is the file, the contents may be intermixed by nature. For example, if two different processes trying to write some information on the same particular file, at that instance, the information that will be written into that file will be intermixed by nature. So there needs some kind of an synchronization, and this can be achieved with the help of an file lock mechanism, that is the appropriate API meant for locking a file until unless its usage has been done with that particular file. So and hence this file lock mechanism helps a lot with respect to accessing a file or accessing a data by two or more number of an process at the same time. Let me just consider two different process called as an process P1 and other particular process called P2, and we have a common file called F1. Let me just treat this as an file F1, and it has some amount of information. Some amount of information is being typed in this particular document. At that instance, if I access this particular process P1 for the same document called F1 in terms of an write mode, that is this process called P1 is trying to access this data in the write mode, that is it is trying to write some information to this particular file. And same time, if a second process called P2 is also accessing the same file called F1, and this particular file is being accessible by process called P2 for the sake of writing information, at that instance the information that will be typed into this particular file will be intermixed. That is the order in which these two different processes are being given a chance to execute, the data will be returned to the file, and at the end of this particular process we can expect the data to be intermixed by nature. So this leads to a greater complexity with a data concurrency, where exactly the data, if a different process wants to access some older version of the particular content, at that instance it will be really tough during this particular consequences. To avoid this particular circumstances, what exactly Unix also facilitates, it actually provides file locks, an API function for which with help of which you can able to acquire a lock on that particular file, so that until unless the necessary or required operation is been completely done on that particular file, no other particular process can able to access the same particular file. That is how the data or this particular read or write operation on the same file can be made as secured one. And at the same time, this lock mechanism by a process on a file can be acquired something like this. It can acquire a lock on some portion of a file or else an entire file. So it means to say that the lock mechanism on the particular file can be imposed on a portion of a file or the interested area in which the data has been present, or else a lock can be acquired on a complete file. That is how a particular process can able to secure its data until unless its read or write operation on the same file is been successfully been done. In view of the same, what exactly this Unix facilitate is, it actually provides two different types of an lock. One is an write lock, the other one is an read lock. So these two are the different types of an locks that are being provided at Unix environment, with the help of which a process can actually secure the file for its operation. Let me just take up this very first one, that is an write lock. Suppose if a process called P1 is accessing a file called F1 and it wants to write some information, at that instance, if it is acquired a write lock on it, it means to say that no other particular process can able to perform read or write operation on it. It means to say that if a process has been acquired with a file called a write lock, it means to say that no other particular process can able to access the same file, for example, for read operation or else an write operation. Where that is what this particular write lock is all about. Where in case of a read lock, suppose if a same process called P1 is accessing a file called F1 and it has been acquired a lock called read lock. At that instance, what actually the nature of this particular read lock is, this actually prevents other particular process to share the read lock, but write lock is being restricted. Where in case of a write lock, both this read operation or read lock or else an write lock is been restricted. Where in case of a read lock, other particular process can also acquire a read lock on the same file, but other particular process cannot access write lock on that same particular file. It means to say that when a process is acquired a lock called a read lock on a file, it means to say that no other particular file can tries to write information to it, but other process can actually read the information from that particular file. That is how this read lock and then write lock will differ. So we will know more about how exactly a lock can be imposed on a file and what are the different parameters that are being involved in this particular process. This write lock as well as the read lock is also known to be, write lock is also called as an exclusive lock and read lock is also called as an shared lock. Why these two names for write lock and then read lock is very simple, as we are clear that if any process is accessing the file and been acquired a write lock, at that instance it tries to prevent any other process to acquire either read lock or a write lock on the same file. It means to say that it is this particular file is an exclusive usage of that process, and hence the name this write lock is also known to be exclusive lock. Where in case of a read lock, suppose if the same process has acquired a read lock on the file, at that instance it allows, that is it shares the read lock with other process same time on the same file. Where in case of an write lock, it doesn't allow any other process to acquire write lock on that file, and hence it is said to be a shared lock because it shares read lock with other process but it doesn't allow other process to acquire write lock on it, and hence the name write lock is also known to be exclusive lock and read lock is also known to be a shared lock. And Unix, based upon the Unix versions, Unix version 5 and its older versions will facilitate the locking mechanism called mandatory locking mechanism, and Unix version 5 and recent versions will provide advisory locking mechanisms. So what exactly this mandatory and advisory locking mechanism is? Very simple. Whenever a process is actually accessing a file, at that instance in Unix version 5 and its older versions, by default lock was been imposed on that particular file. So no matter what, whether read lock or write lock is been acquired on it, by default lock was been imposed on the file, and hence the name it is known to be mandatory type of locking mechanism of a file. Where in case of an advisory lock, the Unix version 5 and recent versions will facilitate the advisory lock mechanism, where exactly it is up to the interest of an user to acquire a lock on that file or not. This mandatory lock is also can be think of mandatory exclusive lock as well as mandatory shared lock. So what exactly mandatory exclusive lock is? If a process accessing a file called F1 and by default the lock is been imposed, and if that lock is of type write lock, at that instance it will be called as an mandatory exclusive. If the same particular file is being accessed and the mandatory lock that has been imposed is of type read lock, then we call it as an mandatory shared lock. So there are only two different ways, that is, if the mandatory lock that has been imposed on a file is known to be write lock, we treat them as an mandatory exclusive lock, and the type of a lock that has been imposed on a file is of type read lock, then we call it as an mandatory shared lock. That is with respect to the nature of the locking mechanism that used to happen with the Unix version 5 and its older versions. So there exactly it actually had a drawback. The drawback is, suppose if the process, runaway process accessing a file and the lock that has been acquired is of type write lock. If that is the case, basically we are all clear what exactly a runaway process is. Runaway process is a process which begins with its execution but it never terminates. If that is the case, we call them as an runaway process. If a file has been accessed by a runaway process and the lock that has been acquired is of type write lock, at that instance that same file is known to be cannot be accessed by any other process until unless this process terminates. So this is drawback with respect to the mandatory exclusive lock. For example, if a runaway process is been accessing the file in terms of an write lock, at that instance the file was said to be not been accessible by any other process for their operation, to perform read or write operation. That is a major drawback with respect to the mandatory exclusive lock. We got to know what is the drawback of mandatory locks. Where in case of an advisor lock, so what actually this advisor lock is, it is very clear that is Unix version 5 and recent versions do facilitate advisory locking mechanisms. So what exactly advisor locking mechanism is? Very simple, it can be explained with three main steps. That is, if whenever a process wants to or access any file, at that instance tries to acquire a lock on that file. Okay, so this process will tries to access the file to acquire a lock on that particular file. Suppose if that particular file is been accessible or been locked by any other different process, at that instance this process should wait. This process should wait until unless the other process that has been acquired a lock on the same required file to release. And then when that file has been released by the process, once again it tries to access a lock. Once this particular lock has been acquired, perform required read or a write operation on the file and then release the lock. So these are the three main steps that has been followed by advisor locking mechanism process. Where exactly any user that he wishes to access a file, at that instance the process should try to attempt getting a lock on the file, and if the lock has been not achieved because of same process, the same file accessed by a different process, at that instance wait until unless the file is being released by the process. When the file has been released by the process, once again tries to access the lock on it. Once the lock has been achieved, try to perform the required reading the information from the file or else writing the information to the file, and once this operation has been done, release the lock. This said to be the principles of advisor locking mechanism. Here this advisor lock mechanism, there exists another drawback. The drawback is very clear. Drawback with respect to this advisor locking mechanism is these three steps are need to be followed by any process that tries to access a file. If not the case, it will end up with a not accessible to our resources, and hence care must be taken when following these three steps to access the content of a file. Yeah, this is about the two different principles of locking mechanism, that is an mandatory locking mechanism and the advisor locking mechanism. These two are named based upon the Unix versions it actually facilitated for the acquiring a lock on that file. And in our previous session, when talking about file APIs for a general file type, we also discussed a file API called FCNTL. And during that discussion, I clearly mentioned that FCNTL is being used for setting or query of file attributes of an opened file. Whenever a file is already been opened, and if we desire to modify the access modifier flags of that file, we can get it done with the help of an FCNTL API. Where in case of Unix version 5 and recent versions, will make use of the same FCNTL API for the file lock mechanism. And hence now let us know what is the function prototype for file lock mechanism, and what are the different arguments that can be passed for it, and what is the different possible values that can be passed for each and every arguments for the FCNTL API for locking mechanism. Yeah, this is the function prototype for FCNTL which has been used for file lock mechanism. And you can notice the FCNTL API, the function prototype for FCNTL API is very similar to the API what actually we discussed in the previous session, which was been used for setting or modifying modifier flags for any open file. Where exactly here in this particular case, that is Unix version 5 and recent versions will provide this, will make use of this FCNTL API for file lock mechanism. Now I think you will be getting confused what exactly the answer needs to be mentioned during your exam if being asked for FCNTL, isn't it? So it is very clear, if your question is all about briefly explain FCNTL API, at that instance you need to mention the FCNTL API for setting or accessing modifier flags of an open file. Okay, suppose if they ask you like explain in brief file lock mechanism, then you need to take use of this type of an FCNTL API for the discussion or the explanation. Okay, so this is said to be the very most repeated question in the previous semesters of a similar course, and hence a file lock mechanism is very important for your exam point of view same time. And coming back to this API, this FCNTL API, all these possible values are being listed in the header file called fcntl.h, and hence using that header file whenever you are been using FCNTL is very much required. Then coming to the very first argument for the FCNTL, which stands for file descriptor. So as you are clear, file descriptors will actually refers to which file we are trying to acquire a lock or to check a lock on that particular file. So this specifies for which file we are trying to check or acquire lock on that file. Okay, where exactly the second argument command flag, this specifies what is the type of an action we are trying to perform on the set file, whether that operation is about checking the lock or to setting a lock. We need to specify the second argument, that is a command that signifies the nature of the action we are trying to impose on that file. And the third argument is said to be the optional one. It will be used only if you are trying to impose a new lock on that particular file. Okay, let me just take up the all possible values for a second argument called command flag. So the different command flag that are available to pass is, very first one is set lk, f underscore set lkw, and f underscore get lk. So what exactly the usage of these three command flags is, the first two are being used to perform or impose a new lock on the set file. That is, we are trying to impose new lock on this file with the help of these two different command flags. And the last one is to check what is the lock that has been acquired on the specified file. So coming to this set lk and set lkw, the major difference between these two is, when this particular set lk has been used, it will tries to check whether a lock is been acquired on the file or not. If lock is been acquired by a different process, at that instance it will not block the execution, it will return back to the process saying that lock is not been achieved due to the same process or same file being accessed by a different process. Where in case of an set lkw, suppose if this command flag is been used for a second argument, at that instance this process tries to check or tries to acquire lock on the file if that particular file is already been accessed or locked by a different process, at that instance it will wait until unless the lock to be removed or the lock to be released. And once the lock has been released, the new lock will be imposed on it. That is said to be a blocking mode of execution. This is said to be non-blocking mode of execution. Non-blocking in the sense, if that file is already been accessed by a different process, it will not wait, it will directly return back to the process, where exactly this second argument is about acquiring a lock on the file. It actually wait until unless the lock is been acquired on that file. And the last one is, that is an Getlk. This is about for checking or to know whether the file has been acquired by any other process. We can make use of this particular command flag called Getlk, which will tries to retrieve the lock status of the specified file. That is what the usage of this, and for this it doesn't require the third argument, where in case of the first two different command flags, it requires the second and the third argument to be specified, and that third argument is the structure called flock. So we need to pass address of this particular structure called flock, where exactly this contains the details of, so what is the type of lock we are trying to impose on that file, and where exactly we are trying to impose that lock, and what is the size of the locked region and the process ID. All this information will be stored in a structure called flock, and the address of this particular flock will be passed as a third argument. And coming more onto this flock, the structure of flock, it contains these different parameters. The very first one is, it specifies L type. So L type in the sense the lock type, whether in this particular L type the possible values are whether it may be acquiring a read lock, or whether it is an acquiring of an write lock, or to release an existing lock. At that instance, we need to make use of these appropriate values, that is f_read lock, f_write lock, and f_unlock. So these are the three different possible values what exactly we can pass for the type for the first parameter of this flock structure. And coming to this, we are quite aware the type of lock that needs to be acquired, that is whether it is a read lock or write lock on a file. Now comes the question, to what area of that particular file, or to which particular region of that particular file am I interested towards acquiring a lock, isn't it? To specify that, we make use of this second parameter called whence. This actually specifies the area of in which the lock needs to be acquired of that particular file. Okay, that is a usage of this L_whence parameter for this flock structure. And this has 3 or 4 more different possible values called as an seeker, seekset, secant, and len. So this actually specify the offsetting of the modification of offset address. As we are quite aware, the offset address will be point to the current location. At that instance, if at all if you really want to change the offset of that particular offset address, at that instance we can get it done with the help of a parameter called whence. So if I specify if I need to add the offset from the beginning, I make use of this possible value called seeker, and seekset is to the beginning, seeker for the current offset, and secant to the last location, and len specify the length of that particular region of which we need to acquire a lock. Then the next parameter is len. This talks about what is the size of the bytes of data that needs to be put into that locked region. So that is what the parameter called lens corresponds to. And the last one, that is an PID. This PID is nothing but the process identifier of the process which is trying to access lock on the file. So which particular process is trying to access a lock on the file, that particular process PID will be stored on it, so that eventually in other particular process trying to access or trying to acquire a lock on that file, it will get to know this process status, which process has already been acquired. We can get to know with the help of this value, a parameter called PID, and hence this PID has to be passed in a flock structure. So this is about the file lock mechanism in this particular topic, it is very clear. The things to be remembered is there are two types of a lock, that is a write lock and read lock. Write lock is also called to be exclusive lock and read lock is also known to be shared lock. We call that write lock as an exclusive because it prevents any other process to acquire read or write lock on the same file. If a read lock is been used, read lock is also known to be shared lock because it actually shares the read lock but it prevents other write lock on the same file. And we also got to know, based upon the Unix versions, there exist two different locking principles. One is an mandatory locking mechanism, the other is an advisory locking mechanism. In mandatory locking mechanism, whether a process has been manually executed the file lock mechanism or not, by default lock will be assigned, and we got to know there exists a mandatory exclusive lock and mandatory shared lock based upon the type of lock that has been acquired mandatorily. And we got to know the drawback of this mandatory lock same time. And then we learned about advisory lock and its three main steps, that is to tries to acquire a lock. If lock has been already been acquired by a different process, it will be supposed to wait, and once the lock has been released by a different process, it will acquire the lock and tries to perform read or write operation and then release the lock. This is said to be the advisory principles that needs to be followed, and hence it is up to the interest of a user, and if a user fails to perform with this particular flow, then it will be put onto the trouble for accessing a file. Then we got to know the function and prototype of an FCNTL and all different possible values of that can be passed for these three different arguments. And the return value of this FCNTL API is 0 if it is said to be success, -1 that corresponds to failure of execution. So failure we can expect only if other process has acquired a lock on it and there is no provision for this process to acquire a lock on that same, or else if a said file descriptor is of a invalid file descriptor, even at that consequence a failure of execution can be observed in this process. So far in our discussion we have discussed various number of APIs meant for general file type. Now let us know the different APIs meant for a device file API, a directory file API, a FIFO file API, and then a symbolic link file API. So we'll get to know more on what are the different possible APIs that are being used to interface these four different file types. So let us know about the different APIs for directory file API and device file APIs, FIFO file API, and then symbolic link file APIs. So to interface or to access a directory file API or device file API, a FIFO file API and a symbolic link file API, there exist and unique APIs which are meant for doing that job, whether it in case of an creation of that file or deletion of file. So this each one of this particular file type has its own different APIs, with help of which a user can able to interact with that particular file, that is creation of a file or interacting that contents of a file and then the termination of a file. So let us know more on this directory file API, what are the different APIs that are being allowed in this directory file. Yes. So these are the different APIs meant for interfacing with the directory file type. So as we are quite aware, directory file type is said to be a file type which can capable to store or have different files in it, whether it is another subdirectory files or any other regular files. So this directory file can store or record other files on it. So to interface this directory file, these are the different APIs that have been meant for it. The very first API is mkdir. This is an API with help of which a new directory file can be created. Suppose if we want a new directory to be created in which other file types can be stored, and at that instance we make use of this mkdir API. And in your Windows machine, you are quite familiar to create a new folder or directory, you will make use of a creation of a folder, isn't it? you will just make use of a creation of a new folder and then you will rename. That is how you can do it in this Windows machine, where exactly in an Unix it is all about a command interface. So the appropriate command used to create a new directory is mkdir, and this mkdir takes two different arguments. The very first one is the path name of that directory file, the other one is an mode. This mode is about specifying the access mode for that file. What is the different access permission that needs to be given for a user, group and others, that can be specified with the help of an argument called mode, which is very similar to the argument that has been discussed during the open API of a general file type. That is, it's said to be, it can take an octal type of an integral value, and that represents the access permission for users, group and others. So this is the API that has been used to create a new directory. Then the next one is an open dir. So in our discussion of an general file type, we come across one API called open, with the help of which we can able to access any regular file, isn't it? So if at all, if we want to access any file for the sake of read or write operation, at that instance, before doing that, we need to make use of an API called open, because open is an API which will create a connection between process and then a file, isn't it? Like that same, even directory file type has got an API called open dir. So open dir is an API with the help of which a process can access a directory file. It creates a connection between a process and then the directory. Basically, we are quite familiar. The directory can store, it is of a recording file which can store the information of a file and its inode numbers. So which are the different files present in that directory file. It will actually records this set of information, that is a record file name and then the inode numbers. So whenever we want to access that particular directory file, we need to make use of an API called open dir. And the next one is an read dir, which stands for reading the directory file. Suppose if we really want to read the contents of the directory file, at that instance we make use of this API called read dir, with the help of which we can able to read the directory file, which will have information about the different file names present in it and the different inode numbers of respective files. And the other API is close dir. Suppose if a process is been accessing a directory file and it wants to end the connection, at that instance it can make use of an API called close dir, with the help of which the connection between the process and then the directory file can be terminated. And the next API is rewind dir. So this rewind dir is, for example, let me just consider a directory file has got 10 different files in it, and at that instance the present pointer is for a 5th file. At that instance, if you really want that pointer to be reset to the beginning location, at that instance we can make use of an API called rewind dir. Rewind dir is an API with the help of which we can able to reset the position to the beginning location of a directory file for the next usage of its accessing a file, and it will take the file descriptor of the directory file. So the possible value for this rewind dir is the file descriptor that corresponds to the file descriptor of a open directory file. And the last API, that is an rmdir, which has been used to delete an directory file. So this can also be implemented with an API called unlink. So unlink is an API with the help of which an hard link can be decremented, isn't it? Same time the file will be deleted, and at that instance it will decrement the hard link by 1, and which particular file whose hard link count is set to be 0, that file entry will itself be deleted. Okay, and this rmdir will actually tries to delete the existence of that specified directory file. The only possible value is the path name that specifies which directory this rmdir should remove from the file system. That is about the different APIs meant for this directory file type. Coming to this, the second file type, that is a device file type. Since we are clear about this particular device file during our model 1 discussion, that is device file actually represents the physical devices connected to the system. Any physical device connected to an Unix operating system, the machine, at that instance each and every device will be treated as a file, and hence this interfacing with that particular physical device means with the help of an file itself. So this is the only API that has been used to interface with the device file API, where exactly that API is mknode. Mknode is an API with the help of which a new device file can be created. Once the device file is being created, later part we can actually make use of read and write API itself for the accessing of that particular file type. So this mknode has three different arguments. The very first one is an path name that specifies the file absolute path name that needs to be created, and the next one is a mode that specifies the access mode for users, group, and then others, and the last one is an device ID. We are clear about this, that is then the device ID that corresponds to, since we know that for any single machine it can have a more number of an external devices or physical devices that can be connected. To identify each one of these particular device that has been connected to a system, it will have that ID that corresponds to the appropriate devices or physical device connected to the system, and hence corresponding to that particular device ID is a must whenever we need to interface with that physical device. In view of the same, there existed two different numbers called a major number and a minor number. This major number specifies what type of that particular device is, and the minor number specifies that appropriate device. And we're all aware of this particular device drivers. Basically it is a software which has been used to interface that physical device. So whenever you plug a new device to your system, at the in the very first stage, it will tries to install that device driver software in your machine, isn't it? When you just plug the same device for the second time, it won't tries to install because the device driver is already been stored in your machine. Okay, and that device drivers are nothing but the piece of code or the set of instructions that specifies the way in which the information can be read or to be written to that physical device. Okay, and that is what this API, that is mknode, that corresponds to access of a physical device file. And in this device file, you might have learnt about two different device files are there, that is an character device file and a block device file. For both, this mknode is the same API to create that particular file. Coming to this FIFO file type, the API that has been used to create a new FIFO file is mkFIFO, and this mkFIFO API takes two different arguments. The very first argument is the file path name, that the absolute path name that needs to be given for that file, and the next argument is an mode. Once again, this mode corresponds to the access permission given to users, group, and others. So this is the API with the help of which a new FIFO file can be created, and we are all pretty aware that is FIFO is being used to as a temporary file, and this FIFO has a greater application with respect to inter-process communication between any two different processes. Yes, we are all quite aware that is FIFO is said to be a temporary file, and this FIFO has been extensively been used for sake of inter-process communication between any two different processes, and we'll learn how exactly this FIFO can be used for the inter-process communication in the later stages. Now it is the API that has been used to create a new FIFO file. Yes, coming to this symbolic link file type. So these are the three different APIs meant for interfacing with a symbolic link file, and symbolic link is nothing but creating a dynamic link for an existing file. That is, with the help of which you can actually access the same file with this newly created link. So coming to the very first API, that is symlink, with the help of which it takes two different arguments. The very first argument is the origin link, that is the already, if a file is already been present in your file system, you need to specify that file path name as the very first argument, and the second argument is the new path name, that is the new file name to which that same file should corresponds to the or map to the existing file, that is the new link for the existing file. It is the only two different possible values it takes for the symlink, that is the creation of a new symbolic link for an existing file. Then the next API is read link, with the help of which you can able to read the symbolic link file. With respect to this API, this API has three different arguments. The very first one is the original link, that stands for the file path name of that symbolic link original file name, and the next argument is the buffer. It is a temporary buffer where exactly the read data is been temporarily stored, and the last one is size. This corresponds to the amount of data that needs to be read from that symbolic link file. Okay, so this is very much similar to your read API of general file type, where exactly the arguments are the same kind, that is the file name followed by the temporary buffer followed by the size that corresponds to the amount of data that should be read from that file. And the last file is lstat. So during our discussion of stat and then fstat API of a general file type, we got to know that stat and then fstat is been used to check or file attributes of any existing file, isn't it? So stat and fstat is been used to retrieve file attributes of an existing file, and that particular type of file should be of regular type, and we cannot specify a symbolic link to retrieve the file attributes. If at all, if we really want to retrieve file attributes of an symbolic link, this is the API, that is the which contains a symbolic link followed by the structure called statv, that will have the details of the attributes of specified file. So the link that has been specified, this particular file attributes will be stored in an structure called statv, and that is how we can retrieve the attributes of the set file with the help of an lstat API. So these are the three different APIs of a symbolic link file type. And in your exam, they may ask something like an directory file type and list and explain the APIs of a device file, FIFO file and symbolic link. At that instance, it is just sufficient if you just list these APIs and give its appropriate explanation. Okay, so in today's session we have been done with discussing the file lock mechanism, file APIs for directory file and device file, FIFO and then symbolic link file. Yes, thank you.